The first day we did regular function composition with square roots. We did it with things raised to third powers, 9 powers, etc. We looked at the quotient and product rule. Yesterday we looked at tables. I think tables are really helpful because they allow you to see the outside, inside, but with numbers. So now we're going to add in trig. So you want to find the derivative of y equals sine x squared. So what function would you define as the outside function? That does? Perfect. So what's my inside function? Yeah, x squared. So if you follow the rule of the chain rule, it's the derivative of the outside. Derivative of sine is so it's derivative of the outside times derivative of the inside. So it's the derivative of x squared. So the derivative of sine x squared is 2x cosine x squared. All right, so sine squared x is really the same as what? Sine squared x. So we can rewrite sine squared x as sine of x squared, right? Because technically what you're saying is that you have sine x times sine x, because it's sine squared, which means you have the sine of x twice. So we're going to do a comparison of the chain rule versus the product rule. So on the right is the old way. I would have given you sine x times sine x. And you would have said, okay, that's the first times derivative of the second plus the second times derivative of the first. So sine x cosine x is really 2 sine x cosine x. Because it's like AB plus AB, which is 2AB. Yeah, dear. No, if you forget, you could do that. I mean, so that's the product rule, right? Where do you see the chain rule? And then you might not be asking me this question. So what's the derivative of something squared? Yeah, 2x, 2 of that something, right? So the chain rule says 2, the inside stays, you subtract 1 away from your power, so it's just 1. Then you take the derivative of the inside. Well, what's the derivative of sine? So in the chain rule, you're just done. The derivative of sine of x squared is 2 sine x cosine x. All right. I got it. Number. I saw your thing about coming eighth. That's totally fine. I just was teaching them, so I couldn't answer back. All right. So what is my outside function? What is my inside function? So what's the derivative of a square root? What's the derivative of secant? Well, as Alex learned, cleaning it up, yeah, it's easier to write secant x tan x over 2 square roots of secant x. Or if you like to be fancy, this is really like secant to the first, and that's the 1/2. So it's really 2 square roots secant x tan x. But either of these are fine. I just got so hungry. Maybe it's because you guys are always eating. All right, find the derivative of y equals 6 cosecant 10x. So the inside is the angle. So the derivative is 6. What's the derivative of cosecant? Good. Times what? Perfect. Exactly. So it's negative 60 cosecant 10x cotan 10x. So what's the outside function? The inside function? So this is kind of like saying f of g of x. And again, I'm just showing you the notation where it's the sine of cosine x. So you can post cosine, which is like your g, inside f, which is like sine. That's all it is, function composition. So the derivative is outside. So what's the derivative of sine? So you get cosine, cosine, x. And where you have to be really careful is where you put the x's. It's not cosine x, cosine x. It's the cosine of the cosine of x. Exactly. Times the derivative of cosine x, which is negative sine x. No. I mean, I'm more partial to writing it as negative sine x so you don't lose your negative. Or sometimes students confuse that negative as a minus sign. So I always rearrange my terms, especially when we would start to get a product rule with a chain rule. So I would rewrite it as negative sine x cosine x. And you just want to be really cautious of where you put your parentheses, etc. If it helps you, you can put parentheses around the x on sine x as well. Yes. No. Because cosine of cosine x is not the same as cosine squared x. Because cosine squared x is cosine x times cosine x, where this is the cosine of the cosine of x. It's kind of like an f of x, as opposed to f of x times f of x. Do you kind of see the difference? Perfect. That's why I like doing the tables before the trig, because I think it helps to see like the way you compose the functions. So this is actually a 3-part derivative, because you have the outside of the inside of the inside. I can't help you right now, I'm sorry. I have my roster kids. So, hold on, let me pause there. So this is really like an h of f of g. So if I ask you to define h of x, f of x, and g of x, because I told you that this is like an h of f of g, what is my h of x? What is my f of x? And what is my g of x? So if you just looked at this and you think about yesterday's table derivatives, what would the derivative of that be? What's the derivative of h of f of g of x? Perfect. So now, what's the derivative of cotangent? What's the derivative of sine? And what's the derivative of x squared? So if you do the problem like we did it yesterday, you could actually write out this and then substitute in your h primes, f primes, etc. Not that you can't just automatically take the derivative. I just want you to see why the derivative is kind of like what it is in terms of all the trig functions. So your dy dx is h prime, which is negative cosecant squared f of g, which is sine x squared, times f prime, which is the cosine of g of x, which is x squared, times g prime of x, which is 2x. So again, everything in yellow you don't actually ever have to do to solve this problem. I just wanted you to have a better understanding of how or why the problem looks the way the problem looks. Or if trig derivatives in general give you an issue, you can always write down their individual derivatives before you start. Your final answer would be to simplify that. So I would write negative 2x cosine x squared times cosecant squared sine x squared. Now, Corey, I saw your hand up. Do you still have the same question, or do you forget? Did I lose you? Think about if I asked you to write f of g of x. That g of x function goes in for the x in sine x. Does that, like, do you see what I'm saying? Okay, so I'm going to give you like a totally random different scenario. So like if I told you you had f of x equals sine x, and you have g of x equals x squared, and let's say you have u of x equals 3x. Then in this case here, we said that this is f of g of x, even if you ignore the h. So if I told you this on a test, you would take this and replace that, right? So it's f of x squared, which then that replaces this. You see how that works? That's why there are x's in all those originals. Because then if I ask you for f of u of x, it would be like f of 3x, and that would have been sine of 3x. But you still need your original to have an x in order to accommodate for that. Yes. Yeah, you can. The order with which this and this are written doesn't matter. No. It just has to be at the very front. I don't care what term you put it with. And leaving the 2x anywhere other than at the front, typically as students tend to misplace it, lose it, etc. Commutative, so can be any way you want. Remember, it's the cosecant squared of this. The x is replaced with f of g of x, which is the sine of x squared. Did you catch up with that thought process, Des? Yeah. Okay. Oops, I went backwards. Okay. You definitely have two more examples, don't you? Okay. So we have the sine of sine. I don't think my PowerPoint from last year saved, so I needed my last two examples. All right. This is kind of like a quotient rule. Anytime you have a trig function squared, before you do your derivative, my suggestion is to rewrite it with the squared on the outside so you see the chain rule. So the derivative, or dy dx, wow, I'm off my screen, is equal to ho d high. So the derivative of sine x squared, perfect, minus high d ho, derivative of cosine is all over, yep, yeah, well, only if it's bracketed like up top. You cannot write sine x squared. It would have to be in parentheses like this. Because if you write it without the parentheses, you're squaring the x and not the function. Do you see the difference? No, you're good. That was a good question. So this cleans up. You could factor out if you wanted a sine x. Yes. I mean, not really, because that 2 is going to mess up making it simplified, but that's what I was looking for. So I was saying, okay, if I take out a sine x, what does that leave me with? Well, it leaves you with 2 cosine squared x plus sine squared x. So initially, when I saw all of the squares, I was hoping to convert sine squared plus cosine squared to 1, but it did not work. Because there's a 2 in front of the cosine. No, because there's not a 2 with the sine. If the problem had started and the denominator had had a 2, then it would have let us pull out a 2 because it would have made it negative 2 sine x, and then each term would have had a 2. So honestly, if it was AP, they probably would have thrown a 2 in the denominator, and I might change my notes for next year to do it. So then this becomes cosine squared x, and there's nothing really to simplify. This one, go multiplied by this one to give me this. Now, if you're not a big product or quotient rule fan, what other way could I have rewritten sine squared cosine x? What is sine over cosine? So then that could have been dy dx equals the first times derivative of the second plus the second times derivative of the first. Are you trying to compare the two answers? Yeah. You wouldn't know to simplify to that?
Yeah, that's just with the grocery rule, I always have something I can get, and I know what's in it, I know how it works. More comfortable.
Okay. And then the last one's what? Sine of sine of sine?
Sign of sign.
Okay. So what's the outside? So what's the derivative of sine? So it's cosine, sine of sine, times the next one, exactly. So the derivative of sine, once again, is cosine. And that doesn't simplify. And Alex, those are your primary killers.
Yellow's a primary? Yeah. Be careful when you get the primary color. What concept is if it mixes with another color. No, if it nothing mixes with another. What are you gonna mix together to make blue? Nothing. I don't know how colors. We're doing calculus, not coloring. But you can't. A primary color is something that you